Assalamualaikum students. Today we will solve question number 9, 11, 13, 15 and 19 of exercise 3C. So this is question number 9. The red die has a number 1 on one face, the number 2 on two faces and number 3 on three faces. So basically we have a die, this one, and obviously it has 6 faces. So 1, 2, 3, 4, 5 and 6. So number 1 on one face and the number 2 on two faces, 2, 2, and the number 3 on three faces. So this is actually the complete sample space of this particular die. Two green dies each have the number 6 on one face. Another die, two dies, sorry. Obviously it has 6 faces. This one is red and this is green. So two green dice each have number 6 on one face, the number 5 on 5 faces, 5, 5, 5, 5 and 5. Similarly another green die, one, 2, 3, 4, 5 and 6. So this is the sample space of this green die. So the 3 dies are rolled together. Part A. Copy and complete the tree diagram shown below by writing the possibilities on the branches. So this is actually the tree diagram drawn in the book. Basically this is for red. This is red die and you can see that there are 3 numbers for red die, 1, 2 and 3, and the other 2 dies are green dies. First green and this one is second green. Now we have to write the probabilities. So you can see in the sample space there are the probability of getting 1 on the red die will be only 1 on one face, so it will be 1 by 6. Number of ones divided by number of faces, 6. For getting 2, number of 2's are 2, so 2 divided by number of faces, 6. Similarly for this 3, there are 3 faces which have 3 written upon them, so 3 over 6 the probability. For getting and these are independent events because what we get on the first green is not affected by the red die, so these are independent events. So the probability of getting 5 will be, there are 5 on this on first green die, so the probability will be 5 by 6, and getting 6 only 1, 6, so 1 over 6. Similarly 5 over 6, 1 over 6, and same case for the this third die or second green one, 5 over 6, 1 over 6, 5 over 6, 1 over 6. So we have completed this tree diagram. Next part B. Using the tree diagram, calculate the probability of obtaining part 1, 2 on the red die. part 1. 2 on the red die, 5 on the green die, and 6 on the second green die. So you have to find the probability of getting 2, 5 and 6. So which branch has 2, 5, 6? This one. 2, 5 and 6. So this branch, this one. So it has 3 probabilities, 2 by 6 and this one, 2 by 6, 5 over 6 and 1 by 6. So the answer will be 10 over 216 or 5 over 108. Okay, next part. 3 on the red. Probability of getting 3 on the red. 6 each of the 2 dice. So 3, 6, 6. So 3, 6 and 6. So this branch. So it has 3 by 6 multiply 1 over 6 multiply 1 over 6. So we get 216 3 or 1 over 72. So this is the answer of part 2. Part 3. Exactly 2 sixes. Exactly 2 sixes. So it means it can be probability of getting 166 or probability of getting 266 or probability of getting 366. As you can see that in each exactly 2 sixes exist. So probability of 166 you can see in the tree diagram, it will be 1 6 is 1 by 6, 1 by 6 and 1 by 6. For getting 266, so it is 2 by 6 multiplied by 1 by 6 multiplied by 1 over 6 and finally 366. The probability of getting 3 in the red is 3 by 6 and other are 1 by 6. So simplifying it, 1 over 216 plus 2 over 216 plus 3 over 216. So we get 6 over 216 as they are like fractions. So 3 2s are 6, 3 72 or 2 1s are 2 and 2 36 or 72. So answer is 1 over 36. Alright, next part 4, a sum of 12. Probability of sum of 12. So we'll go back towards the tree. This column is actually for sum. So 1 plus 5 plus 6, 6 plus 5, 11 for this branch, 12 for this second branch, 1 6 5 12 1 6 6 13 2 5 2 5 5 12 this branch, 12 2 5 7 plus 6 13, then 2 6 5 13, 2 6 6 14, 3 5 5 13, 3, 5, and 8 plus 6, 14, 3, 6, 5, 14, and 3, 6, 6, 15. So how many 2's it has? 12 it has. Sum of 12. This one, and that one. So there are 3 12's, and then probability there are probability of 1, 5, 6, probability of 1, 6, 5, and probability of 2, 5, 5. I'm writing the probability and adding them. 1, 5, 6. Then 1, 6, 5. Then probability of 1, 6, 6. No, 2, 5, 5. So 1, 5, 6. 1 over 6, 5 over 6, and 1 over 6. One, 6, 5, 1 over 6, 1 over 6, and 5 over 6. Plus probability of 2, 5, 5. 2 by 6, 5 over 6, multiply 5 over 6. Simplifying it, 5 over 216 plus 5 over 216 plus 50 over 216, or 60 over 216. 6 tens are 6 threes are 18, 36. 2 5s are and 2 18s are. So answer is 5 over 18. Next part 5. A sum which is divisible by 3. So divisible by 3. Okay, we're going back. Divisible by 3. So the first one, it is divisible by 3. This one as well. This one, and final one. So it means we have to add these probability, and we from previous part we have found the probability of these 3, so we can just add the probability of this into the previous part probability to get this. So probability found in part 4, I'm writing here. Probability found in part 4, yes, plus probability of getting is 15, which is 366, probability of 366. So in part 4 we got a 60, this is 60 over 216, and probability of 366 is 3 over 6 multiplied 1 over 6 multiplied 1 over 6. 3 over 6, 1 over 6, 1 over 6. So we get 60 over 216 plus 3 over 216, or finally we get 633 over 216. So 9 7s are and 9 2s are 18, 36, 9 4s are this. So answer is 7 over 24. Question number 11. Statement is the table below shows the number of male and female employees working in the front office, middle office, and back office of an investment bank. You can see the table. Three representatives, one from each department, are selected in random to attend a seminar. What is the possibility that all the representatives are females? It means in part 1 we have to find the probability of female, 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 female. So probability of getting female from front office will be total number of females are 36, you can see that is, and total number of employees in the front office will be 40 plus 36, 76. And then from middle office, the probability of getting female will be female 35 divided by total number of employees in this department, in this office. So it will be 90. 55 plus 35 is 90. Multiply by back office, total number of employees who are female are 52, and total number of employees in this office will be 32. 38 plus 52 gives you 90. So 36 multiplied by 35 multiplied by 52, so it gives you 65520 divided by 76 multiplied by 90 multiplied by 90. So reducing this fraction, we get 91 over 855. Part 1. Next part 2. All representatives from the front office is a male while the other are female. So it can be, so actually we have to find this probability of getting male from the first, the representative from the first office is the male while the others are male, female, female from the front office. Another combination can be probability of getting first female, female, then male, or probability of getting first female, then male, and then female. So we have to add all of these probabilities. So probability of getting the male, then female, female in the front office. So 40, number of males 40 divided by total 76, then multiply by, as we have taken one male out of it, so it means the number of males left will be 39, or and females obviously 36, but the total, there is the one decrement in the total, it will be 75. And from this again we have to increase 1 in the total, and female will be 35 now, and the total will be 74, as we have taken one female out of it. So this is the probability of this male, female, female, and then probability of getting female, female, and male. Female are 36 in the start and total are 76. Then if we have taken one female out of it, so the female left will be 35 and total 75. Now we have to write the probability of getting male. So 2 female already taken, so total will remain 74, and males obviously 40, plus then probability of getting female, male, and female, 36 over 76 multiply male are 40 divided by total 75 left. Now female 36, now 35 left, already one female taken. So subtraction, actually we had to find the probability of one male. I forgot one thing, actually one representative is taken from each office, so it means we have to find the probability of male, female and female. So the probability of male in the front office will be 40 over 76, whereas the female in the middle office will be 35 over 90 multiplied by back office female probability will be 52 over 90. So multiplying these fractions, we get 182 over 1539. Right. In the third part, exactly one of the representatives is a male. Exactly one male. So it means it can be probability of getting male, female, female plus probability of female, male, female, or probability of female, female, male. So we have to add these probabilities, because in all of these probabilities exactly one male exists. So probability of getting male, female, female, male, 40 over 76 multiplied by female, 35 over 90 multiplied by 52 over 90. This is for front office, this one is for middle, and this one is for back office. Similarly, if this combination exists, first female from the front office, it will be 36 over 76 multiplied by male from the middle office, 55 over 90 multiplied by back office female, 52 over 90 plus this one probability of female, female, female from the front office, probability will be 36 over 76 multiplied by female from the middle office, 35 over 90, and male from the front back office will be 38 over 52. So we have to simplify them. So the answer will be 5591 over 15390. Question number 13. 10 cards are marked with letters P, O, P, R, O, P, O, R, T, I, O, and N. So 10 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And written P, R, O, P, O, R, T, I, O, N. So these are the 10 cards. These cards are placed in a box, right? 2 cards are drawn in random without replacement. Calculate the probability that the first card bears the letter O. So in part 1 we have to find the probability of getting O. So how many O's? 1, 2 divided by total number of 1, 2, 3. So 3 over total number of cards are 10. So this is the probability of getting the O from the box. Second part, the cards bear the letter P and O in that order. P, O, not in any order. It is actually probability of getting P and O. So probability of getting P will be, how many P's? 1, 2. 2 divided by total number of cards 10. Now we have taken this P out of it, so it means 1 P left and total number of cards left are 9. Suppose this has removed. Now we have 9 cards. So probability of getting O will be 1, 2, 3. 3 cards are O. 3 cards. 1, 2, 3. 3 O's divided by total number of cards 9. So the answer will be 6 over 90 or 1 over 15. Third part. The two cards bear the letter P and in any order. So it can be probability of getting PO or probability of getting OP. So probability of getting PO is actually 6 over 90 I have found in this part, plus probability of getting PO, so it will be POP. So there are 3 O's, 3 over 10 multiplied by 1 already taken, so 9 left. How many P's it has? 2. So 6 over 90 plus 6 over 90. So we get 12 over 90 or we get 2 over 15. 6 2s are 12 and 6 15s are 90. Part 4. The two cards bear the same letter. So it will be probability of getting P's plus probability of getting 2 R's. Yes, RR plus probability of getting 2 O's plus probability of getting no repetition, P R O, only 3, only 1 T, 1 I and 1 N, so they cannot repeat. So that is why we have to find these probabilities and then add them. So probability of getting P will be how many P's? 2 P's. So 2 over 10 multiplied 1 P already taken, so it will be 1 over 9 plus probability of getting R, 2 R's. Yes, 2 R's. So 2 over 10, 1 taken, so 9 left and only 1 R left for second R, plus probability of getting 2 O's. There are 3 O's, so 3 over 10 multiplied by 9 left one now and 2 O's left, so 2 over 9. So we have to add these probabilities, 2 over 90 plus 2 over 90 plus 6 over 90 or 10 over 90 or 1 over 9. So this is the final answer. Question number 15. Box A contains 7 blue balls and 5 yellow balls. So blue, 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 7 blue balls and 5 yellows. This is the sample space for box A, and for box B contains 3 blue balls and 7 yellow balls. 3 blues, 7 yellows, 1 2 3 4 5 6 and 7. So this is box B. One ball is removed at random from box A, placed into box B. After thoroughly mixing the ball, a ball is drawn at random from box B and placed back into box A. So actually we have to take one ball from it and then mix in box B, then take one ball from B and then put in box A. So this is actually experiment. So draw a tree diagram illustrate this experiment. So the first draw box A, blue, yellow. This is actually box A. Box B, it can be blue, yellow, and for this blue, yellow. So we're getting blue in the box A. 1 2 3 4 5 6 and 7, 7 blues, so it will be 7 over total number of balls are in box A, 12. So 7 over 12 for getting yellow, 5 over 12. So if blue taken from box A and then we have to add in box B, this will be another blue, like I'm writing here blue. So there are 4 blues now in box B. So getting B or blue from box B, the probability will be 4 over total 4 plus 7, 11. And for getting yellow, 1 2 3 4 5 6 7, 7 over 11. Alright, for the next one, I'm removing this now. If the yellow has been taken from box A, then the yellow will be another, I'm adding this yellow in this box B. So 1 2 3 4 5 6 7 8. Now 8 yellows in the box B. So the probability of getting blue will be 3 over 8 plus 3, 11. And for getting yellow, the probability will be 1 2 3 4 5 6 7 8. 8 yellows divided by 11. So this is the complete tree diagram. Part A done. Next part, part B. Find the probability that at the end of the experiment box A has more yellow balls than blue balls. So if I extend this for the box A again, so if blue chosen from B, then the probability it will have another blue taken and blue added. So blue taken already in this and blue from added. So this will be 1 2 3 4 5 6 7. So 7 over 1 2 3 4 5, 12. And if blue taken and y added, so there will be another y here, 1 2 3 4 5 6. So the probability will be 6 over total 12 for getting the yellow in box A. And if a blue taken so blue taken from one box, then add in B box, and then y taken from B. So it means we have to add in this. So the probability of getting blue will be, you can see that 1 2 3 4 5 6, 6 over 1 2 3 4 5 6, 12. And for getting the y, we have again 6 over 12. And if a y taken and blue added, so there will be blue, another blue. So getting the probability of blue, yellow from box A. This is for box A, sorry. Yes, box A. So the probability will be y taken and blue added. So probability of getting blue will be 1 2 3 4 5, 1 2 3 4 5 6 7 8, 8 over 12. Now for getting y, it will be 4 over 12. And y taken and y added, so there is no change. Probability of getting blue, it will be same, 5 over 12 and 7 over 12 and 5 over 12. So you can see that in each case number of blue balls always greater than the yellow balls. So there is no chance of getting more yellow balls and than blue balls from box A. So that is the probabilities will be 0 in part 1. Part 2, exactly 7 blue and 5 yellow balls. 7 blue and 5 yellow balls. So where is this? 7 5, yes, 7 blue and 5 yellow. So the probability, so there are two branches. This one you can see that 7 blues and 5 yellows. So this branch, first one is this, and the second one is this, 7 blue and 5 yellows. So we have to multiply the probabilities, or add the probabilities. This 5/12 multiply by 8/11. So finally we get 17/33. This is multiply sign. Twice as many blue balls as yellow balls. Twice. So this branch, twice blue balls are 8 and yellow balls are 4. Actually it's double of number of yellow balls. So the branch gives it, this branch gives. So the third part, answer will be 5/12 multiplied by 3/11. So we get 15/132, or equal to 5 3 is 15. So 3 5 is 15 and 344 is 132. So this is your answer. Question number 19. Says a game is such that a fair die is rolled repeatedly until a 6 is obtained. Find the probability that the game ends on the third roll, and the game ends on the fourth roll. The game ends in the fourth roll. So for third fair dice, it means has 6 faces: 1 2 3 4 5 and 6. So on the third roll, the actually part A first. So it will be for probability of getting the. I have to make the tree diagram for it, for 3 tosses. One, 2, 3, 4, 5 and 6. This kind of tree diagram will be made. So basically we have to find the probability of getting 6 in the third row, or probability, it can be obtained from 1 minus probability of getting 1 फिर क्या बकवास है, इतना लंबा सवाल दे देते हैं। So this is second part for fourth roll. This is for first 3, 5 over 6 multiplied 5 over 6 multiplied 5 over 6, and then getting 6 1 over 6. This is game ends on the fourth roll. So it will be 125 over 1296. Third part, the game ends by fourth roll. By the fourth roll, it means it can be game can end at first roll, second roll, third roll, or fourth roll. It means we have to add their probabilities. Third part. So probability of getting 6 in the first, or probability of getting 1 to 6 or 6, or probability of getting 1 to 6, 1 to 6 or 6, plus probability of getting 1 to 6, 1 to 6, 1 to 6 or 6. So all of the probabilities. So first one is 1 over 6. This plus this probability will be 1 to 6, 5 over 6 multiplied 1 over 6, and this one will be 5 over 6 multiplied 5 over 6 multiplied 1 over 6, plus probability of getting this will be 5 over 6 multiplied 5 over 6 multiplied 5 over 6 multiplied 1 over 6. So finally we get 671 over 1296. So part 3 done. Part B. Suppose now that the game is such that same die is rolled repeatedly until 2 6 are obtained. Two 6 are obtained. Find the probability that the game ends at third roll. So it is actually part B. First, probability of getting 1 to 5 ends on the third roll. So it will be 6 and 6. So 5 over 6 multiplied 1 over 6 multiplied 1 over 6. So we get 5 over 216 in part 1. Another combination will be 6 6 plus probability of getting first 6 and then 1 to 5, then 6. So we have to add their probabilities as well. The probability we are getting of 6 6, so 1 over 6 multiplied 1 over 6 plus 1 over 6 multiplied 5 over 6 multiplied 1 over 6 plus 1 over 36 plus 5 over 216 multiplied by 6 multiplied by 6. So we get 6 plus 216, 6 plus 10, 16. Actually I forgot, which is actually game should end at third row, so it means we have to remove this probability. So finally we get 25 over 216. So this is your answer. Second part, the game ends on the third roll and the sum of the score is odd. Third roll and sum of the score is odd. So it means to get the sum of odd numbers, we should have 2 even numbers and 1 odd in order to get the sum odd. So I'm writing here probability of getting the odd plus then even and then 6. Odd plus probability of getting first even then odd, then 6. So getting odd, the probability will be 1 over 2, obviously, because there are 3 odd numbers and 3, so it will be 3 over 6, or you can write here 3 over 6 multiply by even, same probability, 3 over 6. You should have right 1, 3 and 5, 1, 3 or 5. So the 3 and even, it cannot be 6, so 2 or 4, so it will be 2 over 6. And then 6, 1 over 6. In part 2, the probabilities will be, one number should be odd. Then 6 and then 6, or probability of getting 6 odd and 6. So odd numbers are 3, 1, 3 and 5, so probability will be 3 over 6. Multiply 1 over 6 and 1 over 6, plus similarly getting 6 is 1 over 6, then odd 3 over 6, then 6 1 over 6. So we get 3 over 216 plus 3 over 216, or 6 over 216. So finally we get 6 1 6, 6 36, 216, so answer is 1 over 36. So I'm giving you some home assignment. Same exercise. Questions are: nine, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. Okay, take care. Allah Hafiz.